Today, first of all, we are looking for a question, that is, we have a problem section. That is question: if vector v is a differentiable vector function and f is a scalar differentiable function, prove that divergence of fv equal to f into divergence of v plus v dot del f. That is, we are given a differentiable vector function v and a differentiable scalar function f. Then we want to prove that divergence of fv equal to f into divergence of v plus v dot del f. Okay, then we want to start from left side and want to prove that right side. Okay, starts from divergence of fv. Then by the definition of divergence, we have divergence of fv equal to, how can we write to the divergence of a function, that is a vector function? That is, suppose our function is f, then divergence of f is denoted by del dot f. Here instead of f we have f into vector v, that is divergence of fv equal to del dot fv, where del is the gradient vector, that is dou by dou x I cap plus dou by dou y j cap plus dou by dou z k cap dot fv. That is the dot product of two vectors, that is gradient vector and the vector fv. But here the components of gradient we know, but the components of the vector fv which is not present, that is the general equation or general form. Okay, that is we don't know how the components of fv is look like. Then we taking the dot product of gradient vector and fv by general. That is how we can take the dot product, multiplying the ith coefficient of gradient vector and vector fv and the coefficient of j and the coefficient of k. Then we get I dot dou by dou x fv plus j dot dou by dou y fv plus k dot dou by dou z fv, where dou by dou x is the coefficient of gradient vector and the coefficient of gradient vector, ith coefficient of gradient vector, and fv is the coefficient of fv vector. Okay, and similarly dou phi by dou y and dou by dou z. Okay, then we going to partial derivation of fv with respect to x. That is, we taking the product rule for partial derivation, that is I dot f into dou v by dou x plus dou f by dou x v. That is first function into derivative of second plus derivation of first function into second function. That is I dot f into dou v by dou x plus dou f by dou x into v plus j dot f into dou v by dou y plus dou f by dou y v plus k into f into dou v by dou z plus dou f by dou z v. Look this expression. Here we have I dot f into dou v by dou x, j dot f into dou v by dou y, k dot f into dou v by dou z. Then we taking the f commonly outside. Similarly for I dot dou f by dou x v, j dot dou f by dou y v, k dot dou f by dou z v, where v is common, then taking that v part outside. Then we rewrite f into I dot dou v by dou x plus j dot dou v by dou y plus k dot dou v by dou z plus dou f by dou x I cap plus dou f by dou y j cap plus dou f by dou z k cap dot v. Okay, look this expression in the bracket of f, that is I dot dou v by dou x plus j dot dou v by dou y plus k dot dou v by dou z, which is the del dot v. Okay, gradient of the vector function v, and the dou f by dou y I cap plus dou f by dou y j cap plus dou f by dou z k cap is the gradient of f, that is del f. Then we can write this expression as f into del dot v plus del f dot v, that is del dot v which is the gradient of v, that is the del dot v is the divergent of v, that is we can write f into divergent of v plus del f dot v. That is when we taking a vector function v and a scalar function f, then the divergence of fv equal to f into divergence of v plus del f dot v. Okay, clear? Then next question: if v is a differentiable vector function, prove that divergence of curl v equal to 0. That is, we have a differentiable vector function v, then we want to prove the divergence of curl v equal to 0. That is, first we consider a vector v, then taking whose curl, then whose divergence is equal to 0. That is, divergence of curl v equal to 0. So we start. Let v equal to v1 I cap plus v2 j cap plus v3 k cap, which is the vector function, that is differentiable vector function. Okay, then taking the curl of v. Okay, that is the curl of v equal to del cross v. Okay, which is equal to determinant I j k dou by dou x dou by dou y dou by dou z v1 v2 v3, where v1 v2 v3 are the components of the vector function v, and dou by dou x dou by dou y dou by dou z are the components of the gradient vector del. Then taking the cross product, then we get dou v3 by dou y minus dou v2 by dou z I cap minus dou v3 by dou x minus dou v1 by dou z j cap plus dou v2 by dou x minus dou v1 by dou y k cap. Then we want to find the divergence of this curl v. Okay, that is divergence of curl v. Okay, the divergence we represented by del dot. Okay, then divergence of curl v we can write del dot del cross v. Del cross v already calculated, then taking the dot product with the gradient vector. Okay, that is we get dou by dou x of dou v3 by dou y minus dou v2 by dou z, where dou by dou x is the component of gradient vector, and dou v3 by dou y minus dou v2 by dou z is the component of the del cross v. Okay, then we get dou by dou x into dou v3 by dou y minus dou v2 by dou z minus dou by dou y of dou v3 by dou x minus dou v1 by dou z plus dou by dou z of dou v2 by dou x minus dou v1 by dou y. Then taking the bracket out and taking the dou by dou x outside, okay, inside, then we get dou square v3 by dou x dou y. That is taking dou by dou x of dou v3 by dou y. That is the 2 times the partial derivation. Okay, dou square v3 by dou x dou y. That is taking dou partial derivation of v3 with respect to y, then taking whose with respect to x. Okay, similarly we get dou square v2 by dou x dou z minus dou square v3 by dou y dou x plus dou square v1 by dou y dou z plus dou square v2 by dou z dou x minus dou square v1 by dou z dou y, which is equal to 0. How it becomes 0? Listen, v1, v2, v3, v1, that is v1, v2, v3 are the components of the vector function v. Okay, which are scalar quantity, then whose mixed partial derivatives are equal. That is dou square by dou x dou y and dou square by dou y dou x are equal. Then listen, dou square v3 by dou x dou y and dou square v3 by dou y dou x are equal. Then here plus and minus, which is cancelled. Similarly dou square v2 by dou x dou z and dou square v2 by dou z dou x are cancelled. Similarly dou square v3 by dou y dou x and dou square sorry, I already cancelled. Then dou square v1 by dou y dou z and dou square v1 by dou z dou y are cancelled. Then we get that's equal to 0. Okay, clear? Then next question. If vector u and vector v are differentiable vector functions, prove that divergence of u cross v equal to v dot curl u minus u dot curl v. That is, we given two differentiable vector functions u and v, that is vector u and vector v. Then we want to prove divergence of u cross v equal to v dot curl u minus u dot curl v. Okay, we starts from left side. Okay, we have two vectors u and v, then taking whose cross product, then taking whose divergence. Then by the definition of divergence, we have divergence of u cross v equal to del dot u cross v, where del is the gradient vector. Okay, then del dot u cross v equal to, where del equal to I into dou by dou x plus j cap into dou by dou y plus k cap into dou by dou z dot u cross v. Okay, where u cross v is a vector quantity, we don't know how the components are look like. Then taking dot product of this vector and this vector, then we get I dot dou by dou x u cross v plus j dot dou by dou y of u cross v plus k dot dou by dou z of u cross v. Next we want to take the partial derivation of u cross v with respect to x, with respect to y, with respect to z. We already studied how the take the partial derivation of cross product, similarly for dot product. Okay, which are this same way when we taking the dot product of when the partial derivative of two products vector. Similarly here we taking the dot cross partial derivation of u cross v, which is equal to I dot u cross dou v by dou x plus dou u by dou x cross v. That is first function cross derivation of second function, derivation of first function cross first second function. Okay, similarly for dou by dou y of u cross v, we get j dot u cross dou v by dou y plus dou u by dou y cross v. Similarly for dou by dou z u cross v equal to k dot u cross dou v by dou z plus dou u by dou z cross v. Okay, then open the bracket and rewrite the terms u cross dou v by dou x and j dot u cross dou v by dou y and k dot u cross dou v by dou z. That is taking u cross terms of u cross terms in together. That is I dot u cross dou v by dou x plus j dot u cross dou v by dou y plus k dot u cross dou v by dou z. The remaining terms are I dot dou u by dou x cross v plus j dot dou u by dou y cross v plus k dot dou u by dou z cross v. Next we rearranging this, that is changing dot and cross. Okay, we have a property, that is we have three vectors a, b, c. Then a dot b cross c equal to minus of a cross c dot b and a dot b cross c equal to a cross b dot c. That is when we interchanging dot product and cross product, the similar expansion, that is a dot b cross c equal to a cross b dot, that we interchanging cross into dot. But when we changing the position of b and c, that is a dot position of b and c, similarly the product dot and cross, that is a dot b cross c equal to minus of a cross c dot b, that is changing the position of c and b. Okay, then we get substitute a minus. Then here we rearranging like that. Then we get minus of I cross dou v by dou x dot u plus j cross dou v by dou y dot u plus k cross dou v by dou z dot u plus next I cross dou u by dou x dot v plus j cross dou u by dou y dot v plus k cross dou u by dou z dot v. Okay, since this property. Okay, then we taking u outside and v outside from this and from this. Okay, then we get minus of I cross dou v by dou x plus j cross dou v by dou y plus k cross dou v by dou z dot u plus I cross dou u by dou x plus j cross dou u by dou y plus k cross dou u by dou z dot v. Okay, then we rearranging this. We want this term first and this term second, that is we this plus and this minus, then this taking second, then rearranging. Okay, then we get that's equal to v dot I cross dou u by dou x plus j cross dou u by dou y plus k cross dou u by dou z plus minus of minus u dot I cross dou v by dou x plus j cross dou v by dou y plus k cross dou v by dou z. Then look this expansion, that is I cross dou u by dou x plus j cross dou u by dou y plus k cross dou u by dou y, which is the curl of u, and this is the curl of v, that is I cross dou v by dou x plus j cross dou v by dou y plus k cross dou v by dou z, which is the curl of v. Then we get v dot curl u minus u dot curl v. That is, then when we taking two vectors u and v, then the divergence of u cross v equal to v dot curl u minus u dot curl v. Okay, understand?